There is a particular kind of military problem that doesn't appear in after-action reports. It doesn't make it into the official histories. It isn't debated by staff officers over maps or raised in headquarters briefings. It lives in the operational gap, in the space between a unit's forward position and the terrain it cannot effectively cover. In the moment when a perimeter comes under pressure from a direction nobody can confidently identify, and the standard response simply doesn't apply. In the autumn of 1943, on a narrow island in the northern Solomon chain, that gap had a name, not an official designation, not a category in any field manual. The men of the 37th Infantry Division, holding the Torokina perimeter, called it the distance problem. And for longer than was comfortable, the institutional machinery responsible for solving it had not caught up to what the situation required. This video is presented for historical and educational purposes only. Bougainville was not supposed to be a complicated campaign. American planners needed a foothold in the northern Solomons, a position from which airfields could be constructed close enough to apply sustained pressure on the major Japanese logistics base at Rabaul. The amphibious landings at Empress Augusta Bay in November 1943 proceeded more smoothly than expected. Within days, a defensive perimeter had been established around Cape Torokina. Engineering units were clearing ground for the first airstrip, and supply lines were functioning. On paper, the operational picture looked manageable, but Bougainville was not a paper campaign. The jungle was dense and heavily layered, almost completely opaque beyond 30 or 40 yards. Kunai grass fields bordering significant sections of the perimeter grew chest-high and moved constantly in the coastal breeze, making it genuinely difficult to distinguish wind-driven movement from deliberate movement. The ground was soft and waterlogged, cut through by root systems that made stable footing unreliable. Sound and light both behaved unpredictably. Distance was hard to judge. Direction, harder still. Japanese forces had been operating in this terrain for months before the American landings. They had adapted their tactics accordingly, in ways that standard American doctrine had not anticipated. The forward reconnaissance teams were the clearest expression of that adaptation. Japanese doctrine placed considerable operational weight on close-in intelligence gathering at the unit level. Field commanders wanted direct, granular observation of American positions, not just where the defensive lines were, but how they were organized, where communication routes ran, and when activity patterns suggested reduced alertness. To gather that information, Japanese units deployed small forward observer teams, typically 2 to 5 personnel, trained for patience and disciplined observation, operating well forward of the main line. These teams would move into position before first light, using the tall grass and jungle fringe as concealment, and remain through the early morning hours. Occasionally, they would conduct limited, targeted fire, not to produce large operational effects, but to create disruption, to interrupt movement within the perimeter, to complicate resupply routines, to prevent American units from operating freely within their own defensive boundaries. The effect was as much logistical and psychological as it was tactical. A perimeter that cannot move confidently within itself loses efficiency. Communication degrades. Supply distribution slows. The attention of NCOs and officers is consumed by managing the immediate problem rather than planning forward. For the units of the 37th Infantry Division holding the northeastern sections of the Torokina perimeter through November 1943, this had become the defining operational reality. The forward teams were present, their effects were being felt, and the units tasked with responding to them were doing so with equipment that had not been designed for this specific problem. In terrain that made the problem harder than it appeared on paper, the M1 Garand was a highly capable infantry rifle. Semi-automatic at a time when most armies still issued bolt-action weapons to standard infantry, it offered a meaningful rate of fire advantage in close terrain where engagements were sudden and brief. In the kind of dense, short-range jungle contact that characterized much of the Solomon Islands fighting, those characteristics were genuinely well-suited. The problem on the Torokina perimeter was not a close-range problem. It was a distance problem. The Garand had been sighted and calibrated for the engagements its designers anticipated it would most commonly face. Its iron sight configuration was adequate at short range. It was not designed for engaging partially concealed targets at 150 to 200 yards under uncertain light and variable terrain. At those distances, in those conditions, practical accuracy degraded not because the weapon was mechanically incapable, but because the combination of sight configuration and firing position requirements made consistent precision difficult under field conditions. Designated marksmen within each platoon had been issued Springfield M1903 bolt-action rifles specifically for this kind of longer-range precision work. The Springfield was mechanically accurate, capable of precision the Garand could not approach in the right position. That qualification was the problem. Sergeant Dale Purcell of the 145th Infantry Regiment, who had been in the Pacific since Guadalcanal, documented this frustration in correspondence from November 1943. The ground available to a prone shooter on Bougainville was rarely flat or reliable. Root systems created elevation changes across a few feet. Mud gave way under pressure. The Springfield stock design assumed a shooter with time to properly establish a position, find level ground, distribute weight, allow tremor to settle. In the field, that time rarely existed. A forward observer team identified at 170 yards gave a designated marksman seconds, not minutes. By the time a stable prone position had been established, the window had typically closed. In the second week of November, across several units holding different perimeter sections, soldiers at the platoon level began independently converging on the same conclusion. The precision problem was not a rifle problem. The Springfield was capable enough. It was a platform problem. A rifle is only as accurate as the position it is fired from, and the positions available in the Bougainville jungle were consistently inadequate. What was needed was a method of stabilizing the forward end of the rifle against whatever surface was immediately available, sandbag, log, earthen berm, in a way that reduced the shooter's natural movement and allowed the sight picture to settle, not a permanent alteration. Something constructible from available materials, attachable without specialist tools, immediately usable. Private Walter Ekman of Company C, 145th Infantry, had worked as a cabinet maker in Cincinnati for 8 years before his induction. When he examined the Springfield's forend, he didn't see a regulation component. He saw a geometry problem. The rifle's natural contact surface, when rested on an external support, was too short and too close to the action center of mass to provide meaningful forward stability. The solution, to someone who thought in terms of contact surfaces and load distribution, was straightforward. Extend the forward contact point. His first version used hardwood from a broken ammunition crate, worked over 2 evenings with a trench knife. He cut a shallow channel along the underside to cradle around the barrel without touching it. Direct barrel contact would introduce pressure inconsistencies affecting accuracy, and attached it to the forend with wire stripped from field telephone cable. The platform extended approximately 14 inches forward of the rifle's natural balance point. When he rested it across a sandbag and looked through the iron sights, the front sight blade held steady in a way it hadn't before. 3 test rounds at 200 yards, grouped within a hand's width of each other, he began using the modified rifle on perimeter watch and said nothing about it. Corporal James Osei of Company A, in the same regiment, arrived at the same solution from a different direction entirely. Osei had spent years in rural Georgia working terrain where improvised shooting support was a routine practical necessity, and had internalized a principle that formal marksmanship training often only addresses abstractly. The number and quality of stable contact points between a rifle and a fixed surface determines the effective accuracy ceiling more than any other single variable in field conditions. His modification used 2 shorter wooden pieces in a V configuration bound to the barrel band with wire, a cradle that distributed weight across 2 contact points and adapted more readily to irregular surfaces. Neither man knew what the other had done. They held different perimeter sections, served in different companies, and had reached their respective solutions through entirely separate reasoning. The convergence was a product of the problem itself. When a specific operational constraint exists and the materials to address it are accessible, the field generates its own answers through the people whose prior experience gives them the most direct language for thinking about that kind of constraint. By late November, the field-built stability platforms were spreading through the 145th Infantry, through the same informal channels all practical field knowledge uses. Direct observation, conversation. The visible evidence of a tool that produced results where the standard configuration had not. Designs varied. Some hardwood, some softwood, some aluminum tubing scavenged from damaged equipment. Dimensions were approximate. No 2 modified rifles were quite identical. The variation didn't matter. Extending the forward support surface to increase stability against an external rest produced consistent results regardless of the specific construction. What all the modifications shared was a status outside the formal regulatory framework. Army regulations were explicit. Issued rifles were to be maintained in standard configuration. Alterations to barrels, stocks, or sighting assemblies were prohibited. The regulation existed for sound institutional reasons: uniformity, simplified maintenance, logistics, and field repair. Most soldiers making modifications understood the regulatory position clearly and had arrived at a quiet, practical judgment. The regulation existed to protect operational effectiveness, and in these specific conditions, the modification served that purpose better than the standard configuration it prohibited. The operational effect was measurable. Platoon sergeants, in sections where modified Springfields had come into use, noticed that forward observer teams were spending less time in the adjacent grass. Pre-dawn probing activity became less frequent and less sustained. Teams that had previously approached within 150 yards of the American line began maintaining greater standoff distances. Captured Japanese documents from this period contain explicit references to changed American precision fire capabilities in specific Torokina perimeter sectors. One report, dated early December 1943, formally recommends increasing the minimum standoff distance for forward observer teams, a direct acknowledgement that the previous standard had become operationally unsound. A second document notes that a sector previously considered routinely accessible for close reconnaissance had become significantly more difficult to approach. Doctrine does not change in response to threats that are not real. The modifications had shifted the effective reach of the American perimeter's defensive coverage, and Japanese procedures recalibrated accordingly. The institutional response followed a pattern familiar to anyone who has studied military bureaucracy. The first phase was enforcement. An inspection in early December 1943 identified modified Springfields in at least one unit. The officer conducting it was acting within clear authority and in accordance with written regulation. He ordered the modifications removed, platforms detached, rifles returned to standard configuration. The disruption to operational capacity that followed was gradual, a measurable increase in probing activity in sections where modifications had been removed, a return of the friction the platforms had been reducing. The soldiers understood the connection. The documentation that might have made that connection visible at division level did not yet exist. The second phase was investigation. Someone at division headquarters noticed a statistical anomaly. Incident rates from forward observer activity were not consistent across units holding comparable perimeter sections. The disparity was too large to explain by terrain variation alone. The question being asked was not who had violated regulations, but why one regiment's operational metrics looked so different from everyone else's. When the inquiry reached the units with more favorable numbers, the modified Springfields were produced and explained. The investigators' response was considerably more pragmatic than the earlier inspection. Whatever the regulatory classification, the data was not ambiguous. Units operating with stability platforms showed measurably reduced impact from forward observer activity compared to units without them. The formal evaluation that followed involved structured field testing, written assessments, and review by the Army Ground Forces Equipment Board. It moved through the approval chain over several months. By the time formal authorization arrived, the modifications had been in widespread informal use across the regiment for the better part of a season. But the authorization did arrive. Construction specifications were documented and distributed to supply sergeants. Designated marksmen across the Pacific Theater received guidance encouraging adoption. The factory-produced version, with better materials and more consistent manufacture, followed in due course. There is a structural pattern here that appears repeatedly in military history, and Bougainville in the autumn of 1943 is one of its clearer instances. Field conditions generate problems that existing doctrine and equipment have not anticipated. Soldiers close to those problems develop practical responses using available materials and knowledge drawn from civilian life. Those responses are informal and therefore sit outside the regulatory framework. The institutional response is initially suppressive, not because the institution is indifferent to effectiveness, but because it is correctly oriented toward standardization, and standardization requires evaluation. The adaptation persists anyway because the people using it can measure its effects in immediate and concrete terms. Eventually, the evidence accumulates beyond what the institution can process as an exception, and the system adapts. Slowly, with friction, but genuinely. The delay between field recognition and institutional authorization is not simply bureaucratic inertia. It reflects a real difficulty. A military cannot function if soldiers modify issued equipment according to individual judgment without any review process. The challenge is calibrating the speed of that process to the pace at which the field is generating problems that require answers. On Bougainville, the calibration lagged. The field produced an answer in October and November 1943. The institution formally acknowledged it in the spring of 1944. The gap between those 2 points had operational consequences that were preventable. The Torokina perimeter held. The airfields were completed and became operational. The campaign achieved its strategic objectives. What happened there in November and December of 1943 remains correspondingly obscure. A handful of soldiers in several different units, constructing wooden platforms from crating material and attaching them to their rifles with communication wire, watching the operational patterns around their sections of the perimeter shift in measurable response. There was no single inventor, no coordinated program, just a problem, and people close enough to it to understand what it required, and enough of them with the relevant background to find the solution the problem was already pointing toward. That is how most genuinely useful tactical adaptations actually develop, not through formal processes, but through the persistent practical intelligence of people working in the gap between what doctrine has prepared for and what the situation actually demands.